Hello and welcome back. Today we are going to go over part 2 of solubility products, and this will involve the ice chart and understanding the basics of how to truly work out one of these equations. So what we have here is a simple equation. We have the dissociation at an equilibrium of magnesium fluoride, and we're going to dissolve it into its magnesium ion and the fluoride ion. So let's start off by saying we have 3 molars of this of magnesium fluoride, and we are going to dissolve it into solution. And so when we dissolve it into solution, we get magnesium and we get fluorine. So what we're going to do is set up an ice chart. We have initial, which is I, we have change, which is C, and we have expectation, which is E. So our initial is 3 molars, because we threw that in the water to get 3 molars, and we initially have 0 of this and 0 of this. And so what we're going to do is have a change occur. We're going to lose a certain amount of this, so it's going to be subtracted. Then we're going to gain a certain amount of this and gain a certain amount of this. The amount we're going to lose, let's call X. And so we're going to lose X amount of magnesium fluoride. And since there's only 1 mole, X will get no prefix. Magnesium ion, well, that we're going to gain the value of X. And since it's 1 mole in magnesium, it will get no prefix. Now fluorine, on the other hand, has a 2. So with that 2, we're going to have a 2x. And so our expectation as a whole is we're going to have 3 molar, or let's just call it 3 minus x, concentration, and we're going to have 0 plus x concentration, and we're going to have 0 plus 2x concentration. Simple enough, right? And so the KSP value, which is written up here for your reference, is equal to the reactants, which is X, and this X represents the magnesium, 2X, which represents the fluoride ion, and the fluoride ion, remember, has a 2, and if you remember back to that last video, the 2 is then inserted as a power symbol above the concentration. I know there's already a 2 here, and why would you put a 2 here? It's like entering it twice. Well, that's actually the way we do it. Math gives us those numbers, and so this is the way we accept it. And if you do it any other way, you're going to get the wrong answer. So we have then 3 minus x for the products. And so what we're going to do is simplify this. So 2, because it's outside of the bracket, will be brought into everything inside the bracket. So we have 2 to the power of 2 and x to the power of 2. So that will give us x times 4x squared over 3 minus x. So when all is said and done, this x will be brought into here, and we will then get 4x cubed over 3 minus x, and that is equal to 7.4 times 10 to the negative 9th. Wonderful and beautiful, right? Now solve for x, right? Well, I think you can tell right now, solving for x is going to be extremely difficult with this cube in here. That cubed power makes one mess of your equation, and I honestly am too lazy to do that, as is almost all chemistry people. Chemists don't like math. Mathematicians also hate chemists only because chemists hate math. And so what we're going to do is simplify this by looking at this x right here. Now we're subtracting this x from 3. What we're going to say is, based on how small the KSP value is, we want a bigger denominator. A bigger denominator creates a smaller KSP value. So subtracting from 3, obviously this x will be so small it won't matter. And so we're just going to pretend that that x doesn't exist and simplify that way. So what we're going to get when all is said and done is x cubed is equal to 3/4 times 7.4 times 10 to the negative 9th. And I'm going to add the syntax as to be as proper as I possibly can. And so by the course of this, we should know that this is equal to 0.75. That is going to be multiplied by this 7.4 times 10 to the negative 9th. 0.75 times 7.4 times 10 to the negative 9th, which is equal to 5.55 times 10 to the negative 9th. And that is equal to x cubed. So what we're going to do is take the cubed root of both sides to get x by itself. And I'm going to simply take 5.55 times 10 to the negative 9th and take that to the power of 1/3. And hopefully you know enough about math to be able to do that and understand how that works, because the average calculator does not have a cubed root button on it. And so what we get is x is equal to 1.77 times 10 to the negative 3rd. And when you count in significant figures, subtracting that from 3 is nothing at all. And so you can then justify as to why we were able to do that. So if you remember back to our original equation, we have magnesium fluoride reacting to form magnesium ion plus fluorine ion. And as a whole, magnesium in the final value is equal to x. So we know the concentration, not to x, and that is in molarity. So we know the concentration of magnesium. For fluorine, we have 2 of them. So fluorine is equal to 2 times the concentration of x, and that is in terms of molarity. And now you have this beautiful solution that is true sometimes. In the next video, which I hope to get out soon, we're going to talk about the addition of a common ion as well as the activation. Activation will then make this equation true for just about everything. However, that is more of the advanced chemistry, which is a lot more fun. So I hope you stay tuned and come back when I have these later videos published.